So it is the exact same thing we watched at the end of class on Friday. I do want you, while you're watching this, to focus in on a few things. Where the gravity erosion is taking place, what it looks like after the gravity erosion takes place, and what kinds of rocks are, or what are some features of the rocks that are being moved by gravity erosion. So we'll start right up where we left off.
Portland, Oregon, February 1996. A mountain begins to move, and for a contractor and his son, there's only one option: get out of the way fast.
Oh my God!
They had just gone head-to-head with one of nature's most powerful and destructive forces, a landslide. The surface of our planet is constantly reshaping itself, and landslides are a major reason. They strike wherever the soil is loosened by rain or tugged by gravity. It can be a rockfall or a raging river of mud. But wherever the ground fails, it can result in massive destruction. On average, landslides kill more than 8,000 people every year around the world. They can crash down without warning and travel for several miles. In the U.S., landslides occur in all 50 states, but some places are more dangerous than others. Landslides usually follow other natural disasters like volcanic eruptions, earthquakes, wildfires, storms, and floods. Steep slopes are obvious places for landslides, as are areas that have been hit by landslides before. But they also frequently occur where people have radically altered the landscape. Hills stripped of vegetation, slopes modified for roads and buildings. And as our cities and towns expand further, landslides become more frequent and more destructive. In 1998, disaster struck the Southern California suburb of Laguna Niguel. Few realized that the man-made hill beneath them could fail. The ground, eroded by heavy rains, began to give way, and the houses came crashing down. 7 were seriously damaged, and 5 of them tumbled down the cliff face. Though the ground cracked and the earth plummeted, no one was injured. The residents of Laguna Niguel were lucky. They still had their town. The following year in Venezuela, torrential rains triggered widespread landslides across a 25-mile-wide strip of coastline in the state of Vargas. Communities were buried under waves of mud and debris. It's estimated that 30,000 people were killed, around 10% of the area's population. Accurate death tolls were difficult to establish because so many people vanished under the mud or were swept out to sea. Though the catastrophe was on a massive scale, it is by no means unique. Such disasters have happened before and will happen again. As long as the earth continues to move, people will live with the threat of landslides.
Okay, so that was a good one, and I have another really quick one too. For this joyous commercial, of course. Okay.
In eastern Tennessee, a dramatic rock slide that will give any driver the chills. It began as a trickle, then it all came crashing down yesterday on U.S. Highway 64. Yikes, it was the second rock slide that morning. Crews had to break up the car-sized rocks to clear the road. Good morning, everybody. How about that? Man, look at that.
So the road wasn't blocked off at the time yet,
Was
even
not.
though there had been a previous.
Where was the camera?
Oh, no.
That's
Good
like,
question.
We are
took
everywhere.
that-
We are everywhere.
Great question.
I'm just going to sit here until these rocks
Look at
come
that.
down.
That is amazing.
Well, there have
Stunning.
been a couple of previous ones. I guess they were watching the movie.
I'm late, honey. I'm late.
Well, you know
It was
what?
a rock slide.
Oh yeah.
All right. Ha 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 ha. So, one thing I want to ask. At the beginning, I asked you to pay attention to what was being moved. What stuff is moved? Everything. TikTok or YouTube must still be playing back there. The crew, so what it sounded like. Anyway, I had just asked what's being moved, and what did you say, Carter?
Everything.
Everything. Whatever is on the hill is moved down the hill. Big rocks, little rocks, trees, cars, pieces of dirt and mud and sand. What? Power lines, literally anything. Gravity doesn't care. Gravity takes anything that's on the hill and pulls it down the hill. When that stuff piles up at the bottom of a hill, what's it gonna look like? A big mess. That's honestly the best description you could give it. It's a big mess at the bottom of the hill. All the stuff that was on top, all at the bottom, all mixed up in a giant mess on the bottom of the hill. I mean, it seems kind of basic, but yeah, that's what you're getting at there. So here is the big ideas for gravity erosion. I don't know why it was page 21 because it's really page 8. First of all, gravity is the driving force for all agents of erosion. So streams flow downhill because gravity pulls the water downhill. Glaciers can move because, again, of gravity. So gravity, without gravity, we wouldn't have any erosion, but we also wouldn't have a lot of things. Gravity's pull on sediments, or gravity pulls on sediments downhill. Sediments can be any size. They're typically going to be angular. So remember how we learned about abrasion, smaller, smoother, rounder? With gravity, they don't have enough time to get smaller, smoother, and rounder. They just fall and break. And then when I say unsorted, actually, I'll let you guys write because I see you're still writing and I can't ask you to do two things.
Thanks for your. What's up? Such a bill.
The way we're doing notes is I'm basically just having you write some key words or phrases down for these 3 types of erosion, starting with gravity. And what I want you to see with these big ideas, or want you to think or do, is when you see these words, you kind of gotta have some bells and whistles going off in your head saying, oh, that's what gravity erosion does. So sediments being pulled downhill. If the Regents is talking about going downhill, your brain should be thinking gravity pulling them down. If you see an angular rock, one way angular rocks could be moved is by gravity, because there's no abrasion happening. And if you see unsorted, now first of all, let's talk about what does the word unsorted mean? Not sorted. I knew you were going to say that. So I guess we better talk about what's sorted. Let's start with your laundry. A lot of people have to sort laundry before they do it. How do you sort it?
Like t-shirts, shorts.
Oh, you go that far? I don't go that far. My mother-in-law does. She only puts jeans in one batch and towels in another batch. I just do more like Sarah was saying. I do typically do like light colors and then a dark color. Sometimes I put like clothes that can't go in the dryer in a different batch too. But you just sorted your laundry. If you just sort it from light to dark, you don't want to mix them together sometimes because
I thought you was talking about when you put it into the.
Oh, putting it away. No, I was talking about before. You don't do your own laundry, do you, Zach?
No.
Yeah, that's what I thought. So whoever does your laundry most likely sorts it for you. Sarah must do some laundry every once in a while. Yeah, but you knew it happened? Okay, when I do the wash, I do separate it into lights and darks, because I don't know if you know this, but if you wash a nice white shirt with some like dark colored clothing, though, there might get some dark color on your white shirt. Definitely reds are very bad to wash with white, because then you get pink. And not a lot of people like wearing a light pink shirt.
I have
I
not.
like white.
I've never had it happen, no matter how much like white shirts.
Yeah, so they do, the laundry detergents that they make now do prevent this from happening. If you do your laundry at cold, it also prevents that. And a lot of the dyes aren't as bad. But have you ever had a pair of those jeans that sometimes they're labeled even that says like, wash them inside out before? I remember I had a kid who wore theirs the very first day, and they had a nice white shirt, and it turned the whole shirt just by sitting with it next to each other. Dyed the shirt the color of the jeans.
My wife.
You've had white socks turn pink, yeah. So you sort, anyway, as long story short, you sort your laundry so that doesn't happen. So I just wanted to make sure you knew what sorted means. So sorted means grouping them in that case by color. Unsorted would be just putting everything in the dry washer at once. So how about rocks? What might be ways that rocks get sorted? Think of all the stuff that's coming down that hill in the video. So I'm telling you it's unsorted, but what might be a sorted by size? Yeah, you might have big rocks getting dropped off first, little rocks getting dropped off last, so you kind of end up with sorted piles. I think somebody else just wanted to mention shape, so round versus, not square, but round versus angular. Sometimes even by material, so certain like densities might settle out faster than others. But with gravity, just like I asked at the very beginning, what does it look like afterwards? It's just a big mess, everything piled up and messy together. So again, what do you need with these 4 bullets? Not necessarily, so notice I didn't put up the vocab like debris flows and debris falls and stuff like that. But if you do hear gravity pulling sediments downhill, think of gravity erosion. Think of angular in shape means gravity erosion was happening. One other thing is they do sometimes have a different name for this, and I'd like to add that to our notes. So right here where it has gravity erosion, the other name for this is what's called mass movement. So gravity / mass movement. You can call it either one. So if you're just talking about sediments being pulled downhill, it is just gravity erosion. The regions might use the phrase mass movement. Again, it's a huge mass. You saw all that stuff coming down the hill. It's a mass of stuff being moved downhill. To be perfectly honest, I don't have much of a drawing for this one. This one I think is the least important for the 3 of them for drawings, but we can add one. It's gonna be super easy. Here is a cliff. When rocks fall down a hill, let's say lots of rocks are gonna fall down. How will they get piled up at the bottom? What's that mean? They're gonna keep piling up on each other. And again, what are they gonna look like here at the bottom of the hill? A mess, all different sizes. So kind of what I wanna show is there's going to be, like if a rock was to fall, it'll fall here. And then if another rock falls, it might pile up here, but now there's room on top. What you're gonna get on the side of the hill, and if you could show different sizes if at all possible, you're going to get this, which is called a talus slope, which is just a pile of unsorted sediments at the bottom of a hill, but they will kind of slope down. Now, if another one was to fall here, it might roll down here, and now there's room for some more. I do think, like I was saying, this is the least important of the 3 pictures we're gonna draw on this page, though.
How do you draw?
Well, we're not gonna draw wind, we're gonna draw a result of wind is what we're going to draw. All right, so I think we're gonna move on to glacier erosion next. What is so funny? Earth science is really just that funny?
Why not?
Because technically I really wanted to do glaciers on Friday, but I thought the videos were better and more interesting for gravity. So I did go out of order.
So we're not watching any videos?
There is no video for these next two, no.
That smells so good.
What? Ew, it's a little weird. All right, so let's start with glaciers. Of course.
What is wrong with you?
Where's
Very
your
left though. She's sniffing white out.
Bro, I was just smelling, it smelled good.
Okay.
She's sniffing white out.
So we're gonna start with glaciers today. This will be the only other one we do today. So let's start off with, do you have any idea what a glacier is?
No.
Snow. Where is a glacier?
Antarctica.
Okay, cold places. Well, also what I wanna get at is a glacier is on land. It could be on a mountain, absolutely. As long as there's land underneath it, it's called a glacier. I've had a lot of people ask me about icebergs. So like an iceberg, like the Titanic hit,
They're in the water.
they're in the water. So icebergs and glaciers, they have similar characteristics, but they don't behave the same way.
No, not really.
So glaciers on land, icebergs in the water. How's a glacier form? Like, we don't have any
The
glaciers outside.
No.
The building.
Yeah, but we have snow outside, how come we
So
don't
like
have
it's gotta be
any?
a lot of snow.
So a lot of snow, we had a lot of snow a few weeks ago.
We didn't mind.
Okay, I did, you might not have, Mr. D and I did, you guys might not have. Why do we not have any glaciers at our house?
Because
Cause it melts. So around here and
it's
in
gonna
Penn,
be cold all year round.
so it at least has to be pretty darn cold all year long. It doesn't necessarily have to stay below freezing, but it does have to stay pretty cold for a while. Even though we don't have too much snow, and you guys definitely didn't have any snow until like the end of last week, where there's still places around town that had some significant amount of snow left over.
No.
You had none, no snow anywhere.
Nope.
Not even some little leftover piles.
Where
No.
they snow plow.
Where they snow plowed. I'm guessing cops had a pretty decent snow pile. There weren't even any outside
The
here.
big large part of them.
The Big Lots Park Club had some left.
Still do it.
There we go. Thank you, guys.
Big lot.
Bigger parking lots end up with bigger snow piles, and they take forever to melt. You'll have snow piles in parking lots way longer than you would like on the grass. One reason is there's more snow. They take all the snow and pile it in one spot. But also, let's talk about how those snow piles feel or look in the Big Lot or the top parking lot or in any parking lot for that matter. And just regular old snow.
No, it's dirty.
First of all, it gets dirty.
Uh-huh.
The dirty. Also, how would it feel? Does it feel like the light fluffy snow that?
No, it's
Solid ice.
It's pretty solid ice, very compacted, like somebody took that nice fluffy snow and squished it all together. But then it also gets like a layer of like pretty thick ice because the snow does melt a little bit, then refreeze, and we get a nice layer of ice. And that ice is often dirty. The combination of the ice and the dirt actually acts to kind of insulate the rest of the snow pile. So it takes it even longer for the snow and piles to melt, not just because there's more of it, but because it's dirty and icy. It takes longer to melt. The last big November storm, 8 years ago, was it? There was snow. So what they do in Buffalo when they can't just plow it anymore, they actually pick it up with not forklifts,
Pilots.
there you go, those things, the things that do this, and they put it in dump trucks. And then they take all the dump trucks to one central location, and there's a place downtown, the Central Terminal, which they don't use too often anymore. And they dump all the snow from basically the whole city in this one parking lot. And last November storm, they broke that snow pile up on Father's Day weekend, which was in June. So it went from Thanksgiving-ish to Father's Day, and it would have still probably been there even longer if they didn't break it up and spread it around. I'm sure the same thing's gonna happen with the snow that's left over from these last 2 storms this year as well.
I wish we had storms up here.
So basically, that pile could have potentially turned into a little mini glacier in that parking lot if they wouldn't have broken it up. They could have just added more snow the next year and so on and so forth. So,
That's where it's eventually melt in the summer.
depends on how much there is and how well insulated it is. It might stay quite a while. I'm sure it could have melted, but maybe if it wasn't a very hot summer, maybe it wouldn't have. It's hard to say.
It's crazy.
But that's how glaciers form. So that's how they form. So my next question then is, I'm telling you that glaciers do a bunch of erosion. What's erosion? Oh boy, if you don't remember what erosion is, maybe turn the page back 1 page, I think. What's erosion? Everybody now, since only like 3 people are doing it, everybody turn your page back 1 page.
The breakdown of that.
No, it's not the breakdown, Rob.
The upward.
The movement. So weather's breaking, erosion's moving. So I'm telling you, glaciers can move sediment, broken pieces of rock. How the heck does a glacier move anything? It's just a pile of snow. I guess I'm asking, how does a glacier move? Yeah, it's a big pile of snow, but how does it move anything? It's just a pile. Yeah. What about gravity?
It
Hold
breaks
it.
and holds it.
Okay, I know.
Hold it down.
Pull it down, yeah, so how does it move something that's only going down? But you're kind of on the right path. So first of all, I got the two.
Passing notes.
Yeah, sorry. I'm gonna read it out loud, Sarah.
Read it out loud, please. Yeah, me exactly got moved right there and then.
Sarah, go over.
Okay, so
Ew.
one thing, so a glacier, which we don't have around here anymore, but we kind of already talked about how they form. So here is a pile of snow from 1 year. And then it doesn't melt. And next year, more snow gets piled on top of it. How much do you think this snow weighs that gets piled on top of it? A lot. I don't know how much it weighs. Could be. I have no freaking idea.
Right there was 25 tons.
Okay, so I mean, it definitely weighs a lot. So I don't know exactly how much it weighs, but I'm gonna go with, just like you said, it weighs a lot. So we have snow year after year after year piling up on each other, and it's really heavy. So if this snow is really, really heavy and I just keep piling more stuff on it, what's this heavy snow gonna do to the snow below it? It's gonna crush it. And what do you see happening with that Play-Doh cup?
I don't know.
It's moving. So the weight of the snow every year kind of works like that, and it pushes its way around the world, in fact. Remember that there also should already be more snow and glacier back here. So it truly only has one way to grow for the most part. So that's one way glaciers can move. Another way glaciers can move is, actually, let's ask, where is it cold all year long?
Antarctica.
Antarctica. Where are some other places?
Greenland.
Okay, not just like places around like individual, like I'm not asking for a specific name of a place.
New York.
Where is another place you might be able to go any time of the year and see snow?
Greenland.
On top of a mountain.
Yes, but also that's what I'm going for. So on tops of mountains. So mountains are cold all year long, so glaciers can form there. And then in that case, how do you think a glacier moves? Slides down the hill. So in the end, both are gravity. So gravity was pulling the snow down on top of each other, and it also causes glaciers to move downhill. That's how glaciers move. So what do you think they're going to move? What can a glacier move? So you said land, houses, trees, everything. So glaciers, a lot like gravity, but also like a giant bulldozer. Glaciers can move absolutely anything in their way. Here's an example of what's called an alpine glacier. Do you know what alpine means?
Isn't there a type of valley?
Nah, it's a mountain. Basically, like alpine skiing, it's mountain skiing. So
Very
here we have
snowy.
glaciers, in a mountain. So you can see in this case, up here, snow is not melting, more snow, and it's sliding down the hill. In the meantime, any pieces of rocks that aren't like 100% attached will get picked up and moved downhill with that ice. You don't need to write this, but basically it's a large stream of slow moving ice that can just move anything. It also will, when it starts to melt, move some sediments as well. Here's some famous features created. So you guys did not need to write those notes that I just had up there. We've got the Finger Lakes. Do you guys know where the Finger Lakes are?
Right there.
Yeah, right there.
Nothing.
They're right there. So they're right in the central New York. They're kind of between Syracuse and, but between Buffalo and Syracuse, you'll run into all the Finger Lakes. Basically just at the start of Rochester over to Syracuse. Why do you think they're called the Finger Lakes?
Because there's 5 of them and they look like fingers.
I mean, it looks like fingers. Looks like somebody took their fingers and just put them right there. We'll talk about how those form, but then we also have these U-shaped valleys. Looking at this picture, any idea why we might call it a U-shaped valley?
They grow in the shape of a U. Or they didn't grow, but
They're formed in the shape of a U. So I know it's kind of a stretch. It's not a perfect U, but you can see it's not a V. It doesn't come to a point at the bottom here. The nice curve, like the edges aren't nice. They aren't very steep like a V. They're a little bit more blunt. So that's a U-shaped valley. You can almost picture a giant bulldozer with its front like thingy, the thing that does the bulldozing, just plowing through here and making a shape like that, or a glacier, because a glacier acts like a bulldozer. Here's kind of how those Finger Lakes formed, or even just any U-shaped valley, is there's already a river valley there. And in this case, can you see that V shape here? So this is a V-shaped valley. What happens is then a glacier fills that valley and just plows through it and makes this nice U-shaped valley. With the Finger Lakes, basically the U's got blocked up and they filled with water, and then you have the Finger Lakes. Again, here's the Finger Lakes, another picture of them. You can see why they're called fingers. They almost look like somebody's just dragging their fingers across. This is called plucking, and you can kind of see how a glacier might pick up stuff. So as it's moving, anything that's even just a little bit loose here, the ice is going to just pick it up and carry it down with it. It's nothing can like get out of the way here. Here's going to be the aftermath of a glacier. So once it's done moving forward and it starts to melt, it's going to leave behind the rocks it was carrying. Again, what do you notice about this mess here? All different sizes. So we've got mud, dirt, clay, sand, silt, got littler rocks, bigger rocks, huge rocks, and an ancient cell phone. That was just put there for size. Now I know you guys have no idea how big that cell phone is. Fun fact, that was my very first cell phone. This is not me taking this picture, but I had that exact cell phone. My very first.
was it one of the big?
No, it wasn't like the big
Looks like a
Zachmore.
TV
It's
remote
one,
to me.
huh?
It looks like a TV remote.
They are more similarly shaped to a TV remote. It was a Motorola, and I was cool as heck having one.
Are you sure you didn't just think you were cool?
No, I knew. Just like you know you're cool.
I had one of them slide up.
No, I don't.
but they
Oh.
didn't like
Work.
Here is another vocab word that goes along with glaciers. This is called a moraine. A moraine is nothing more than, you can kind of see here, it's a pile of unsorted sediment that get dropped off by a glacier. They do usually kind of run along the glacier, so you can kind of see where it was when it melted. Here is another example of a moraine. So there was a glacier here and it dropped off sediments on all the sides where it was melting. Here are some more features. So you can just see these pictures. Anytime you see these bare rocks up in the mountains, those again are caused by glaciers. Here's another one. And some more,
You got enough pictures?
and some more. And some more.
And some more.
There's another one.
Maybe another.
Oh, what's this a picture of?
Finger lips.
No,
Because the U.
the U-shaped valley. So this is a valley that was caused by the glacier plowing through. You can see how big we're talking about the boat. You are very smart. Again, oh, here's a good question. Do you know what when an army retreats, do you know what that means? They run away back to where they came from. What does it mean when an army advances? They push forward. They go forward. Retreating is going backwards. They use those same phrases for glaciers. Because basically because a glacier is as destructive as an army marching through. So a retreating glacier is when would a glacier retreat? When would it go backwards? When it's melting. So the glacier melts, it's gonna melt from the warm side, like where it's warmest first, and then move backwards, and that'll be retreating. If it was moving forward, that would be when it's growing and more snow is getting piled on top of it. One of my favorites, these are drumlins, and they show the direction that the ice was moving. So again, it's a hill filled with unsorted sediments. You can see these a lot around here, all the way over to Syracuse. You can look at the hills on Genesee Road. I talk about Genesee Road a lot because that's where I travel daily. But you can see that they are steep hills on one side, maybe a little more gentle on the other. And they do show the direction of the ice flow. So they start at the blunt end and then the ice flows towards the other more gentle side. I like to think of them as this little helmet thing here. So this is the start, like the wind will hit here first and then go that way on this goofy helmet, but yeah, and this is probably my favorite. These are called kettle lakes.
Cannonball.
Do you know what a kettle is?
Kettlebell.
A kettlebell, yes, but I'm talking about a kettle. Like a tea kettle or kettle, yeah. That's a really good example. Can you picture them making kettle corn?
That big old bowl.
That big old pot. Kind of like, it always reminds me of a witch's cauldron, you know, where they cook children. Oh, wow, how the heck did we not get this far? But those same kettles that they cook the kettle corn or the children in, they have the really steep sides and they're nice and round. That's a kettle lake. So here's how they form. Glacier sits on the ice, on the ground, makes a dent, fills with water. And, oh, my favorite, we'll pick up here tomorrow. No homework, expect some homework tomorrow. Okay, so glacier